are we trying to do? We're trying to find the sum of a telescoping series, this guy. This 1 over n to the third minus n. Then we have to expand it out. We have to expand it out. But first, we factor. We pull an n out. Then we see that's the difference of squares. N plus 1, n minus 1. We suspect that this is a telescoping series, so let's get it in the form by using partial fractions. All right, we take our factored form. Since those are linear factors, I put constants above them. Then after I put constants above them, I'm going to add them. This is nothing to sneeze at. So once I add them, I put it all over the common denominator. This is partial fractions, and we're going through it quick. You can see those videos if you want to see those. Now we goes, and we multiply everything through, and that's how I'm getting that over my common denominator. And then I'm combining like terms. I put my n squareds together, I put my n's together, and then I just had that lone constant, which then, just to make it clear, I rewrote that 1 as on squared plus on plus 1. Of course, that's not on. That's 0 times n. So I'm matching up my coefficients. I'm matching up my coefficients. I match that 0 with that a plus that b plus that c. That's 0, that's c. And then I match my c minus b with the other 0 in my rewritten numerator. Then my constant, my minus a, is equal to that constant. After we solve the system, due to the length of solving the system, we skip to the answers. Okay, so we solve the system, and we get our a to be minus 1, our b to be 1/2, and our c to be 1/2. Then I have to rewrite this series as minus 1 from that a over n plus. Now see, I had a half up top, but I dropped that deuce down to the denominator. And then I had a half up top, and then I dropped that deuce down to the denominator. And that was my expanded series. Now what? I need to go through and I need to find these iterations. So, let me make some room. Wow, that's written big. Okay, I just want you to see what's going on here. So I rewrote our sum expanded out. Now, I'm going to look for the partial sum. So I go and I find S1. S1, bam, that's a 1. Okay, so then what? I call that 1 plus 2 a 3, and I call that 2 minus 1 a 1, and I multiply those guys out, and that's how I got that 6 and that deuce. Now let's go find S deuce, our second partial sum. I do that by putting a 3 in everywhere I see an n, because my series, oh yeah, it started at 2. So that's why we're using 3 for n in our second partial sum. So I called those sums what they are. And I continue on. Let's go find S3. S3, that's 1 over 4 plus 1 over 10 plus 1 over 6. This is not an introductory example. It's not. So we're trying to find Sn. Let's go make some room. I'm going to make this a little bit smaller so that we can see it. Oh, faster, faster. Wow, I'm writing really fast now. Zoom, 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 zoom. I can't even believe I can write this fast. Ugh, I had a lot to rewrite. I could have just get to the answers, huh? Okay, so I'm here now. I'm here now. I'm here now. Because I'm looking for the next one. I'm looking for S4. That's when I put a 5 in for n. And then I'm looking for S5. That's when I put a 6 in for n. Then I'm looking for Sn. But first, I start by finding n minus 2. I'm plugging n minus 2 in here. You'll see why in a minute. Now I'm plugging n minus 1 in there just like I did before. And then I'm plugging n in there. Why? Because I'm trying to find Sn, and it behooves us to find a few terms before the last one, just in case stuff doesn't cancel out. Now let me clean that up and call them what they are. All right. So let's try to find this cancellation. Whoa, see, look at that. the 1/10 take out the 1/5, because the 1/10 plus the 1/10 is 1/5. Now, this is not your introductory example. And the 1/8 take out the 1/4. And the 1/6 take out the 1/3. And bam, bam, bam. That's how the 1/6 gets reduced. And then we look over here. Oh, if you add those two, you get that one. And then if you add that in the previous one, you kill that. And then the killing keeps happening. And that 1/14, that was gone too. So what do we have left? We have these numbers seem to have evaded the fisticuffs, that annihilation, and these terms are also still in there. Why are we doing this? Why are you doing this to me? Because we're trying to find a more difficult example for finding that partial sum. So that's the nth partial sum. How do we define our series? Our series, our original, our OG series, dog, look like that. We rewrote it. Then we recall that the limit as n goes to infinity of Sn is the sum of this series. That's why we focus so hard on finding the sum of that series. So that's the limit of the partial sum, the one we made above. Now notice I took out the 1/2 because they were additive inverses. And now we run the limit on those guys. Oh, 0, 0, 0. Ah. So that whole dang thing adds up to be a quarter. Box and flower.